$4 per acre increase in production over that grazing season. Okay? In the second replicate, and there was a definitive difference in the soil types between these two replicates. In the second replicate, we had a 23% increase, or about a $270 increase in dry matter value over that 150-day grazing season on a per acre basis. And then in terms of total grazing days for that grazing season, we found that comparing the Sumagrow treated pastures to the broiler litter treated pastures, we ended up with 21 more grazing days out of a 150-day season. And then comparing the Sumagrow to the nitrogen treated pastures, we ended up with 33 more grazing days out of that total 150 days. Okay, this is a trial that we conducted just this past year at Aislinn Farms up in Prairie, Mississippi. We had multiple replications in this particular trial, and the treatments that we were looking at, we were using the Sumagrow Forage Boost product, and we applied that at a half a gallon per acre in one treatment and nothing else. Okay. In our second treatment, we applied a half gallon per acre of the Forage Boost plus 50% of the recommended fertilizer, 30 units of nitrogen. Our third treatment was 100% recommended fertilization, and then we had an untreated control. All the treatments were applied in mid-April, okay, at green up. We put, if you knew the lay of the land there, in each area we had ridges and bottoms. So what we did was we stripped our treatment across the ridges and across the bottoms so that in every single treatment and every replicate we had ridge and bottom included in all of that. And then we randomly placed our dry matter yield cages across the ridges and across the bottoms so that we would not bias our results depending upon where the yield cages were located. We collected dry matter samples every 45 days and measured bricks on a weekly basis. We took the dry matter samples to Mississippi State University, to their forage testing lab, and then they did all the measurements for us. So we had a third-party, unbiased source doing the actual dry matter calculations and doing all the tissue analysis for us in this particular trial. Okay, this is applying the product in April, and we used a cluster sprayer to get it out on pasture. This is what the pastures looked like. This was taken about 3 weeks after application, okay? About 3 weeks after initial application. These are the dry matter yield results, okay? In the Sumagrow only, we had right at 3,400 pounds average dry matter yield per collection. In the Sumagrow plus the 50% fertilizer, we had 34.95, so there was no significant difference in dry matter yields between the Sumagrow alone and the Sumagrow plus 50% fertilization reduction. Okay? Fertilizer alone came in right at 2,800 pounds of dry matter per acre and the control at 2,300. And then over in the far right-hand column there, that is our cost analysis valuation. And what you'll find is that in the Sumagrow alone, compared to the control, we netted another $31 per acre. In the Sumagrow, with the 50% fertilization reduction, we netted another $18 an acre. In the fertilizer alone, compared to the control, based on cost analysis, we ended up losing about $12 an acre. Okay, in terms of our bricks measurements across the season, again, from May through September, we found that the Sumagrow treatment is the green line, the Sumagrow plus fertilizer is the blue, fertilizer alone is the red, and the control is the light blue line down here. And you'll note that at the beginning of the season, we we had some definite differences in terms of where we were in our bricks. With the Sumagrow, we did not necessarily see, the Sumagrow alone, we didn't see an immediate rise in bricks, okay? It took 20 to 30 days or so to get that rise in bricks that you'll note throughout the rest of this graph. With the fertilizer, we got a very quick initial result, a quick rise in bricks, which nitrogen application will do, okay? But then we saw a very definitive tapering of the bricks throughout the rest of the season where we had either the control, no fertilization whatsoever, or we had the fertilizer alone. Okay, this particular study most of you have seen before, but I put this in here again because I think it's very important to note some of the benefits that we have seen in replicated trials related to reduction of water runoff and nitrate leaching. So this was a trial conducted last year by Arise Research and Discovery evaluating Sumagrow for the reduction of water runoff and nitrate leaching in corn. And the objectives were to use containment bays to be able to capture any runoff and measure very precisely water runoff and nitrates. There were 3 treatments. There was Sumagrow plus a 50% reduction in nitrogen, Sumagrow plus 100% recommended fertilization, and then our control, which was 100% fertilizer. This is just an example or pictures of the containment bays, and basically all they've done here at their research facility is gone in and dug up the soil to a depth of about 4 feet. They lined the sides and then put tile underneath so that any water that drains goes directly into that catchment that you see there in the front with the lid labeled number 56. This is another containment bay or yield plot that you see here. So that's what they look like. The results are compared in this table in terms of runoff and nitrate leaching. If you look, this is the 100% fertilizer, Sumagrow plus 100% fertilizer, and this column compares these two, and then this is the Sumagrow with the 50% reduction, and this column compares this to the control. So you'll see that in terms of runoff that was measured in both July and September for the growing season time period, we had anywhere from a 47 to almost a 57% decrease in water runoff where the microbes were incorporated into the plots. In terms of nitrate leaching, we had anywhere from a 35 to almost a 57% decrease in nitrate leaching. In terms of yields, they looked at actual yields in bushels per acre. We had anywhere from a 19 to 22% increase in yields with a corresponding increase in leaf chlorophyll. Okay, for 2 years in a row now, we're going into our 3rd year of conducting trials in Montana. And we're looking at a number of crops there that are used in livestock to feed livestock. So these are all basically forage-type crops that are used in feeding livestock through the winters and in feedlot-type situations. And we were evaluating alfalfa and a mix of oats, barley, and winter pea that is a very commonly grown silage crop grown throughout the Midwest and through the Northwest regions. The particular rancher that we've been working with over the last 2 years and will continue to work with this year, he's located near Sheridan, Montana. It's a very beautiful location. He's located in a basin that is surrounded by 4 different mountain ranges. And so they get about 11 to 12 inches of natural moisture a year, counting rainfall and snowfall. So they do depend quite heavily on irrigation, both center pivot and wheel line irrigation, everywhere that they are growing these crops. He is also a well-noted seed stock breeder of both Red Angus and Black Angus cattle and has national exposure